Hello, in this exercise you are calling to demonstrate that or to prove that the current flowing through resistor R1 is equal to R2 multiplied by the main current divided by R1 for R2 plus R1 R2 divided by I3. Here we are going to demonstrate that formula. Let us first of all discover something. Here we have three resistors connected in parallel, meaning that all the resistors will have the same voltage. We can simply write like this. Let me change the color of the pen. Let me take the black one. 12 volt is equal to V1 equal to something is disturbing. V1 equal to V2 equal to V3, which is also equal to I1 R1 equal to I2 R2 equal to I3 R3. Let's call this equation 1. Now, by applying the first law of Kirchhoff, we say that the algebraic sum of the current entering the junction should be equal to naught. We can apply the first law of Kirchhoff at this junction at point A. You discover that the main current here, which is I, is equal to I1 plus I2 plus I3. Let's call that second equation 2. Now, from equation 1 now, we can simply consider only these two items because we are looking the expression of I1 in terms of the main current. Let's say that from equation 1 we are going to write like this. From equation 1 we can write I1 R1 equal to I2 R2. Now the unknown point here is I2. Let us find the expression of I2 in terms of the other element, and from equation 2 we can say that I2 himself is equal to the main current minus I1 minus I3 Let us call that equation 3. Now, by taking equation 3 into this equation, we have now gave the name. We can still call it equation 1 because the expression does not change. By taking equation 3, let us write 3 in 1. We have 2 point I1 R1 equal to I2 himself, which is equal to this element, I2 himself, which is equal to that element. Let us substitute at once. I minus I1 minus I3 all multiplied by R2. Let us expand that equation and see what we are going to have, which is equal to I main current times R2 minus I1 times R2 minus I 3 times R2. We discover now on that equation that the unknown point here again is T I3. From equation 1 again, from equation 1 we can compare this item and this item because all are the same. We can say that we can look the expression of I3 and write like this. From that equation 1 we can say that I3 alone is equal to I3 alone is equal to I1 R1 divided by I3. Let us call this equation let's say equation 4. Now equation 4 in this equation, in this point, let us take equation 4 and come and substitute in this point. We are going to have, means that 3 here, we take it and substitute it up there. We are going to have now let's say I1 R1 equal to main current I times R2 minus I1 R2 minus I3 himself, which is equal to I1 R1 on I3 multiplied by R2, and you discover now you have a common factor, this one, all in terms of I, in terms of the main current. Let us now put that I1 in bracket and see what we are going to have. Let me wipe this item in the middle so that I will get a small space to write properly. Let me take eraser and wipe properly. Okay, now by putting I1 in bracket, we are going to have I1 in bracket. Here remain R1. This item cross the equality by changing the sign. Now we are going to have plus R2 plus now R1 R2 on R3 bracket close equal to this other item, which is equal to I times R2. I hope that you see how the thing is showing itself smoothly. Let me take the eraser and wipe this space. Now I1 alone should be equal to main current I times R2 all divided by R1 plus R2 plus R1 R2 on all R3. And that was the demonstration that I was asking you to prove. I hope that we have proved that exercise. The demonstration have been proved. Okay, if you have any question, just drop me a comment in the description section below, and if you have any proposition for this assignment, just leave me a comment. Don't forget to subscribe, like, share among your classmates, and See us in the next video. Peace.